All right, so today we are going to solve our rational equations algebraically and graphically. The focus is going to be on algebra, but I also want to point out that this can be done graphically very, very quickly. Um, so, um, Same thing we do with our fractions. We are going to apply to rational equations. If I were to try to solve this equation here, I'd likely want to get rid of this denominator, this 6, by multiplying the 6 on both sides. And I would eventually need to multiply the 3 on both sides as well to get rid of that. And if we do that, what happens is those 6 crosses out, those 3's cross out, and we're left with a scenario where we have, 3 times 4 equals 6 times x. Well, we could have gotten that right from the bat by doing this thing called cross multiplying, where we go 4 times 3, which is the same thing as 3 times 4, or 6 times x. And they're going to kind of both work through the same process. We're going to work this down. 12 equals 6x. We can divide by 6 on both sides and get 2 equals x. We're going to follow this same exact process just for rational equations, for stuff that's a little bit different. A couple things to note. Problem 1, problem 2, we are going to do by hand. But problem 3 and 4, we are going to do graphically. So I'm going to just write a quick note here. We are going to graph in example 3. And we are going to graph in example 4 as well. My mistake, I made some examples that were way too complicated and beyond our abilities in math at this current moment. So they are still something we can do graphically, which will be nice. So for example 1, if we're following that cross multiplying process to cancel out the denominators, it's going to look like this. We have this 3 times 2x minus 1. I'm going to throw some parentheses around this just to highlight that we need to use our distribution property. So 3 times 2x minus 1. And that is equal to our other cross multiplication, which is 4 times this x plus 2. Again, I'm throwing those parentheses to help remind us to distribute. Once we have that, we can start simplifying. So that 3 times 2x is 6x. That 3 times negative 1 is minus 3. And that equals that 4 times x and 4 times 2, which is 8. Then we get a situation where we need to use our algebra to solve. So I'm going to kind of split my equation on both sides, start moving all my variables to one side. So I'm going to move that 4x over to the left by subtracting on both sides. That gives me 2x minus 3 equals 8. I'm going to move this 3 over by adding to both sides. That leaves me with 2x equals 11. And finally, I'm going to divide by 2 on both sides and get x equals 5.5. So we can do the same thing with example 2. I'd recommend trying it for yourself first and then checking it against mine. We're going to set up that cross multiplying step. So I'm going to throw parentheses around all of these to kind of help me capture that. So I know I have x minus 2 times x minus 4. And that's equal to this cross multiply on the other side. Throw some more parentheses around it. X plus 3 times x plus 1. Then we are going to kind of start simplifying. So we can use the box method, or we can use our distribution. So I'm going to distribute here. I got x times x squared. So then x times negative 4 is negative 4x. Then I go with my negative 2, so minus 2x. And my negative 2 times negative 4 is plus 8. I'm going to use that same distribution on the other side where I got x times x. Then I have x times 1, so plus 1x. Then I have 3 times x, so plus 3x. And lastly, 3 times 1 plus 3. Now I can kind of combine like terms here. So I see I have on this left side, I have negative 4x and negative 2x I can combine. So we get x squared minus 6x plus 8. And on the right side, very, very similar, we have this x and 3x we can combine. So we get plus 4x and just plus 3. Now I need to work to solve, so we're going to try to move everything to one side. What's really convenient here is if I move either of these x squareds over, we subtract it, and we subtract from both sides, and they just cancel out, which is really nice. So I'm just left with negative 6x plus 8 equals 4x plus 3. Then I want to move things to my other side of the equation, so I'm going to add 6x to both sides, add 6x to both sides. And I chose this direction to keep everything positive, so now I get 8 equals 10x plus 3. I can then subtract that 3 from both sides here. And I'm running out of space, so I'm just going to kind of write this over here. I get 5 equals that 10x. And then finally can divide by 10, and get 0.5 equals x as an answer. Now, real quick before we start graphing example 3 and 4 to solve these, just want to quick remind you at the bottom of your notes, there's quick instructions for that. We want to plug each side of the equation into Desmos' separate functions. Remember how we split those? Then we locate the intersections and find the x values. So let's quick check our answer for example 2, see if that works out. We get a fraction on the left here. I'll write my f of x in here, where we have x minus 2 up top, x plus 1 on the bottom, and then that other function there is x plus 3 over x minus 4. Okay, if I look for these intersections here, it looks like we have a very clear intersection, boom, at 0.5, which does indeed match what we got in our original solution. If I kind of scroll down these continuous spots, it doesn't look like I ever intersect. Same thing as I move to the left or move to the right. So I just got that one solution there at 0.5. Now, we were told ourselves we were just going to graph for example 3. So make sure to kind of split that into two different sides here. On the left side, we have our, I'm just going to kind of write over these things, 2x plus 5 divided by 3x plus 4. And on the right, we get 5x minus 3 divided by 4x plus 1. And you can see very quickly here, we have two different solutions. And this is why we weren't able to do this by hand, because I ended up by accident picking some really ridiculous examples. But we have a solution at this negative 0.96 and a solution at this 2.531. So those are going to be our values there. X equals negative 0.96 and x equals that 2.531. Similarly, we can graph and solve example 4. One that we're going to see very quickly is absurd again. So again, my apologies. On my left side, I'm going to do this 3x minus 4 over x. So I'll do that as my top one here, 3x minus 4 over x. And on the right side, we get that x minus 11 over 12. And I have one solution right here, this 1.044. So let me write that down. X equals, well, I'm going to write down graph. X equals 1.044. And let me explore a little more, see if I have any other solutions. I'm going to keep that kind of highlighted on there. It looks like I'm about to have an intersection as I scroll right. So as I do that, boom, we also have this spot at 45.956. That works out. So x also equals that 45.956. Again, sorry I wasn't able to show you how to work these through by hand. I absolutely meant to, but I will pull some people during practice for the challenge problems so we can see what that looks like.